Hello, sophomores. Today we're going to be doing pre-ACT science practice. I am Mrs. Myers. I teach AP Bio, AP Environmental Science, and Honors Bio. All right, here are my top 5 ACT science tips. Expect unfamiliar content. Don't freak out, right? It's probably going to be about something you haven't heard of before. That is okay. You can do it. Go straight to the questions. I really recommend that you question block. So like do all the questions about table 1, then all the questions about the next thing. Try to do things in order, not of question, but of the passage. That will help you not get confused. Pay attention to labels, titles, and units, and then make sure you write all over the test. All right, this is the passage that we're going to do today. It's from the June 2015 test. You can see here, there's a little intro paragraph. There is table 1, figure 1, and figure 2. I recommend as soon as you hit a passage, circle the titles. That way, when you see, okay, this question's asking about figure 2, I know my answer is going to be here. This is also a figure 2. This is a figure 1. This is a figure 1. This is a figure 1. And this one is a table 1 and figure 2. That way you know where your answers are really quickly. Okay, this little area here, I would not recommend reading this passage unless you fall into this category. If you know you are a fast reader and you know when you read, you will understand and remember, read that little paragraph. Otherwise, it's not a great use of your time. Go straight to the questions, okay? I'm going to ask these questions in order of figure 1 first, then figure 2. Here we go. Try question 37. It's about figure 1. All right, question 37, based on figure 1, so I know we're looking here. It says, consider 2 Kr samples at 293 degrees Kelvin, each with that many atoms, and one is at volume 25 liters, the other one's at volume 50 liters, okay? The first 2 bits of information, the 293 degrees Kelvin and this many atoms, are just all the things in this chart, right? Figure 1 tells us everything's at that temperature, everything's at this number of atoms. So that's not important. However, the volume is important, okay? We're looking at Kr, so we know we're looking at this line here, okay? The first volume is 25 liters, and the second volume is 50. 50 liters is not on this chart. I'm going to have to predict. If I go over, this is 35, 40, 45, 50. 50 liters would be over here, okay? They're asking me, what is the most likely lambda? So what is this value going to be, okay? If we predict where we think this line is going to go, at 50 liters, it's going to be somewhere around 600-ish for the nanometers. Does that look like it's doubled from 25, or does that look like it has quadrupled? The answer should be C. It's about doubled. Here it's around 300-ish. Here it looks like it's going to be around 600-ish. So times 2. Try question 38. All right, question 38 is saying based on figure 1. So again, we are looking at figure 1. For the Xe and Ar, xenon and argon, this guy here and this guy here, at volume 20 liters. So we're looking right here at these 2 dots, okay? Comparing the lambda for xenon, how much longer is the lambda for argon? Okay, this number, it looks like it's around 400-ish, a little bit more. This one, it looks like it's around 200-ish. So your answer for 38 should be J. They're about 200 nanometers apart. The difference between 200 and 400 is about 200. Okay, try question 39. Okay, question 39 is talking about collision frequency, so how often these gas atoms collide with each other. We're looking at a 5 liter and a 25 liter of xenon. So here is xenon, 5 liters will be that dot, 25 liters will be that dot. Okay, comparing these 2 guys. Okay, assuming they have the same speed in both samples, which one will have more collision frequency? Basically, which one will the gas atoms bump into each other more often? If they're at the same speed, that will not matter. But if we look here at 25 liters at this volume, the lambda is bigger. Well, I don't know what that means, so I'm going to have to look in the paragraph. The paragraph tells us Lambda means the average distance they will travel between collisions. Okay, so at 25 volume, they're going to have to travel further between collisions. That tells me this one is probably not going to collide as often if they're the same speed, because they're going to have to go further to bump into each other. So the answer for 39 should be A. The 5-liter one has to travel shorter distances because this lambda was shorter than this one. That one was a tough one. All right, try question 35. Question 35, we're looking at figure 2. Here's figure 2. Okay, what is the order of gas samples from shortest lambda to longest lambda at that many atoms? All right, here's 15. We found 15. Okay, and we're putting them in order from shortest. That'll be your first one to longest. So it should be xenon, then Cr, Ar, and Ne. Your answer for 35 is D. Try question 36. All right, question 36. We are looking at figure 2. Here's figure 2. And we are doubling the Ne, so looking at Ne is this guy, sample size from 6 to 12. Here is 6, here is 12, so we're looking at that dot and that dot. As we double the number of atoms, what happens to our lambda? We're going from 1600 up here to 800 down here. How does that change? It's half as much, so your answer for 36 should be G, half. All right, last question, try number 40. Okay, number 40 is asking about radon. Do I see radon anywhere? No, so we're gonna have to predict, okay? Radon gas, it's in 25 liters at 293 Kelvin. This paragraph tells us figure 2 is about 25 liters, 293 Kelvin, okay? Its lambda is about 320. So this value, if we were to graph this guy, is gonna fall somewhere around here-ish, okay? I'll label that 320, okay? Based on table 1 and figure 2, how many atoms are there? So they're just asking, where does it fall on the x-axis, okay? I know I have to use table 1, so let's look up at table 1. Table 1, radon is not on it, but they do tell us that radon's diameter is 0.240. So I'm gonna write radon into table 1, 0.240. Okay, that looks like it's the biggest, right? When you compare all of these guys. So that tells me if these are in order, neon, argon, krypton, and xenon, radon's gonna fall on the bottom. If we're graphing him, here would be a radon curve, okay? Because he was the biggest, so that means if these all fall the same order, he'll fall on the bottom there, okay? And they're asking at what point will his curve hit the 320, okay? Is it less than 6? Yeah, it looks like we'd be less than 6 here. It's definitely not between 6 and 9, or 9 and 12, or greater than 12 this way. Okay, so the answer is his curve will hit 320 somewhere less than the 6 times 10 to the 23 times. All right, cool. Thanks for watching. Hope you guys had fun.